just quick repetition. There are three characteristics of linear functions that we'll say. And implicitly, let y equal f of x be your typical. It could be f of t. It could be z equals f of r. Be a linear function. As long as the graph is a straight line, slope of the graph is constant, and these two things are intuitively the same. We understand that if the slope never changes, you're going to keep going straight, right? And if you keep going straight, the slope ain't going to change. Okay? More rigorous proofs exist, but we're not getting that rigorous in this course. And then this really, really important concept that nobody seems to recognize: rate of change is constant. Okay? And specifically the rate of change of y with respect to x, or whatever this variable is with respect to that variable. Okay? And you have to know that. We've talked about it, it's in your book, and nobody seemed to know it, so fix that, okay? Everybody got a note to fix that? Very simple. When you see it, you just go, oh. It was so simple, I didn't notice it. It's the most important concept in mathematics as it applies to the real world. Okay? Foundational is the first concept you run into in calculus, whether applied calculus or more rigorous calculus. Okay, anyhow. That's three characteristics of linear functions, right? So we can expand on this just a little bit. I had a big piece of yellow chalk and a big piece of green chalk. I just got them yesterday. And they're both missing already. This is ridiculous. Now, don't worry about it. If you never know what might run out at you if you move anything on the table. I think there's serious evolution going on in here somewhere. Okay. Don't know if we'll get a new species out of it or not, but there's something going on. Okay. Okay. Taking off on these concepts, all of which are the same, really. Okay. We could also say if follows that, and I'm trying to write follow and correct the word if, which should be it. It follows that. The slope of the fundamental triangle for any 2 points is the same as for any other 2 points, right? So if I was going to use AB, and I just suddenly realized I don't want to use AB. I'm going to use a notation that'll invoke a formula that I don't really want to invoke, but I will anyway. If x naught, y naught is a point not come out. If and only slope of the fundamental triangle for this point and this point is equal to the slope of the line. Okay? So, y minus y naught over x minus x naught equals m, where m is the slope. Now, how can I say that? How does this follow from this? Well, what's the slope of the fundamental triangle for x naught, y naught, and xy? Yeah, I'm going to use up word space I'd rather have left, but okay, you got the point x naught, y naught, xy. The run is x minus x naught, the rise is y minus y naught, the slope is y minus y naught over x minus x naught, rise over run. And that's where this comes from. You need to understand that, because that's how I want you to find this equation of a straight line. I don't want you to memorize a formula. I want you to use a picture, because a picture tells you more than the formula does. Okay? Now, of course, if I multiply both sides of this by x minus x naught, what do I get? We multiply both sides by x minus x naught, and that gives us y minus y naught, y minus y naught, equals m times x minus x naught. And that is a formula that used in Algebra 2. And I'm almost certain that it was in this form, with x naught, y naught, and everything else. Okay? So you memorize this formula. Does everybody recognize that formula immediately? Probably not, because you used it long enough to pass the test and then forgot it, because that's the way an SOL-driven curriculum teaches you to learn things. Okay? But you knew this at one time, and if it hasn't stuck with you, it's because an SOL-driven curriculum has its advantages, but it doesn't teach you how to make things stick. This picture sticks. This statement sticks if you understand it, okay? And this is why I emphasize this, as opposed to memorizing a formula that you already memorized and don't remember. Okay? I imagine some of you do, you just don't want to admit it, but that's okay. My experience is that if people remember anything about straight lines, it's that formula, but they don't really know what it means. And as a result, can't do what they need to be able to do with straight lines. Okay? You learn how to do a few can problems and can't go any further than that. And that's not college level learning. So we're trying to engender some college level learning here. Okay? So if it's a little tough, okay. How many times have we done slope equals slope? We did it about the first or second week of class. We did it last week. Okay? And it's on the quiz. So I'm reinforcing something that you will be tested on this week. Okay?